Yesterday, we learned about variables, constants, and speaking equations. Today, we're going to learn about operations. So what is an operation? An operation is a mathematical a mathematical process and the most common operations are addition, subtraction, multiplication, and division. There are other operations, such as square roots or squaring something, but they are less common, and we are only going to focus on these four main ones now. So what is the definition of an operation? An operation is the mathematical processes of addition, subtraction, multiplication, and division. And remember that order is important. So the order in which you do operations is important. Remember when we learned order of operations? When we learned this one here? PEMDAS? That was the order of operations. That was the order in which we had to do operations in an equation. So that's what we mean when we say order is important. Some examples of operations are addition, subtraction, multiplication, division, squaring something, exponents, and parentheses. Non-examples are anything that's not an operation. So maybe just the letter A, the number 11. These are not operations because they are not processes. This is just a variable and this is just a constant. They are not operations. So what are the main operations? They are addition, subtraction, multiplication, and division. Now sometimes when we talk about the four operations, we use different words to describe what we are doing. Sometimes when we're talking about addition, we might say 3 plus 2 equals 5. Or we can say the sum of 3 and 2 is 5. 3 increased by 2 equals 5. 3 more than 2 equals 5. 3 added to 2 equals 5. Or the total of 3 and 2 is 5. So in subtraction, when we are talking about subtraction, let's put the sign up here. When we're talking about subtraction, we can say 3 minus 1 equals 2. The difference of 3 and 1 is 2. When you take the difference of 3 and 1, you get 2. 3 decreased by 1 equals 2. 1 less than 3 is 2. 1 fewer than 3 is 2. Or 1 subtracted from 3 is 2. In multiplication, we sometimes say times the product of, so we can say 2 times the product of 3 and 4 equals 24. Or we can say 3 multiplied by 2 equals 6. I'm not sure about the add example. Let's skip that one for now. And then of, we can say 3 of 2 is 6. Divided by, division. When we talk about division, we sometimes say 6 divided by 2 equals 3. The quotient of 6 and 2 is 3. The ratio of 6 to 2 is 3. And 6 per every 2 is 3. So these are just different ways to say an operation. And I want you to come back and look at this sheet if you have a word problem and you don't know what it's trying to tell you, if you can't identify the operation. So let's try these. Remember the other day when we were doing those problems and you had the first problem was 5 plus x equals 10. And a lot of you used really great math sense and found out that 5 plus 5 equals 10. And the way you figured it out was just by asking yourself, what number plus 5 gives me 10? You were speaking in a sentence and asking yourself a question. And that was how you found the answer. So I want you to get used to solving math problems in this way. This is how we read equations to get familiar. So look at number 1. The what number is always going to be x in the equation. So it says what number plus 4, remember plus means addition. What number plus 4 equals 20? So what number here plus 4 gives me 20? Well, 16 plus 4 gives me 20, so x must equal 16. Try solving this equation again using a sentence. We have 15 minus can be found under the subtraction. So we're going to use 15 minus what number is x equals 6. 15 minus what number gives me 6? Well, I know that 15 minus 9 equals 6, so x must equal 9. What about this one here? 5 times is multiplication. I do 5 times, what number is x? Let's just change this multiplication to a dot, that way we don't get confused, equals 35. What number times 5 gives me 35? Well, I know that 7 times 5 equals 35, so x must equal 7. What about this one? 60 divided by is division. 60 divided by what number is always x equals 12. Well, I know that 48 divided by 12 is 4, right? And I know that, if I go up one more, that 60 divided by 12 equals 5, that 60 divided by 5 must equal 12. So if I know that 60 divided by 5 equals 12, x must equal 5. So this is a non-traditional way of solving equations, but I want you to get used to the language and the way in which you need to talk yourself through math problems. So when solving one-step equations, it is important for you to read the problem to yourself. For example, 6 plus what number equals 14 is read as 6 plus what number equals 14. Think about how you would solve this problem. If I know that 6 plus x equals 14, I know that 6 plus some number gives me 14. What if I just take this 6 away from the x? And remember, the equation has to remain equal because of this sign here. And then I subtracted this 6 from here. 6 minus 6 gives me 0. I have x all by itself over here. 14 minus 6 is 8. Let's check our answer. Does 6 plus 8 equal 14? It sure does. So let's say these equations as sentences. I want you to read the problem here to yourself and then write the question in your head here. So I'll do this one for you. We have 3. Then I have addition here, so I'm going to say plus, then x, which is what number, equals 20. So do you see how I turned this equation into a sentence that I can say in my head that helps me solve the equation? Pause the video and do the rest of these on your own right now. Now check your answers, pause the video, and make sure you got everything correct. Now the next thing we're going to talk about, we talked about operations. Now what is an inverse operation? An inverse operation is an operation that undoes the other. So your definition in your book is going to be inverse operations are operations that undo each other. What does it mean to undo something? Well, let's say this jacket here, this right side out jacket, is addition. If I wanted to undo this jacket and put it on inside out, I would do subtraction. If I said that now the jacket right side out is multiplication, if I wanted to undo this jacket, I would turn it inside out and do division. So for every operation, there is an operation that undoes it. Now I want you to try this exercise here. Look at the page. It says, find the answer to each problem. So do this on your own, pause the video, and once everyone is finished, check your answers here. Did you get these as your answers? Now on the bottom here, it says highlight the first number of each problem. So highlight the first number of each problem. And highlight your answer. And I'm going to highlight my answer. Do you notice anything special about these two numbers? They're the same, right? So then what happened here in the middle? If I add 4, but then take 4 away, addition was my operation, and then subtraction was my inverse operation, the operation that undid the first thing. Here, multiplication was my first operation, and then division was my inverse operation. Here, subtraction was my first operation, and addition was my inverse operation. Here, division was my first operation, and multiplication was my inverse operation that undid the division. Here, addition was my first operation, and subtraction was the operation that undid the addition. Here, subtraction was my first operation, and addition was the second operation that undid the first. So the opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. And the opposite of division is multiplication. So in an equation, when you see a plus or a minus, this is actually a different topic, right? So this is inverse operations. And I want you to kind of grasp onto that. This here is kind of just an interesting thing that I want you to know about variables and the signs that are connected to them. So in an equation, when you see a plus sign or a minus sign in an equation, remember it needs to have an equal sign, attached to a variable or a constant, it belongs to the variable or constant. What does it mean to belong to something? It means that you are a part of it and you cannot be separated from it. So for example, in the equations below, the positive or negative sign belongs to the variable or the constant to the right, which means it cannot be separated. This negative 3 here can, well, here, hold on, let's see. So this negative sign makes it a negative 3x. This positive sign makes it a positive 4. There is no sign here, so we can assume that this is a positive 10x. So if you have a plus or no sign, it's positive. And if you have a negative sign, it is negative. So the sign is also an operation. I know it's confusing, but practice below by drawing a square around the constant or variable and its sign. So here we have a positive 28 because there's no sign. So we know this is a positive 28. This here is a negative 2x. This here is a negative x. And this here is a positive 11. You try this on your own. Pause the video, and when you're finished, check your answers. Did you get these answers? Check them on your sheet. So, in summary, I can use inverse operations to blank constants and variables from blank of the equation blank. Pause the video and fill this out on your own. So the key concept here is that since these signs are connected to the constants and variables to the right of them, I can use inverse operations to move constants and variables from one side of the equation to the other. And I'm going to show you how to do that tomorrow.